Today's lab, Friedel craft acylation of an aromatic substrate. These are electrophilic aromatic substitution reactions. Okay. Where we're going to react an acyl chloride with a strong Lewis acid to create a very strong electrophile, something which is strong enough to get an aromatic to quit being aromatic for a short period of time, go and react with it, and then we're going to redo the aromaticity, causing that stability to come back. So we're going to react an electrophile with an aromatic and substitute that electrophile for one of the hydrogens on the aromatic ring. All right, we're going to do this in the presence of aluminum chloride as a catalyst. Okay, and we want to do the reaction mechanism. Okay. So with acyl halides, the first step then is for the halogen to take the electrons and attack the electron deficient aluminum. Remember, aluminum only has 3 sp valence electrons, so even when it's sharing with the chlorines, it only has 6 around it, so it's electron poor. That gives us our carbocation, and the aluminum tetrachloride as a polyatomic anion. Now that may look particularly nasty. We have a positively charged carbon double bound to our electronegative oxygen, but it is resonance stabilized. Which is enough so that this reaction works. Okay. But it is, however, extremely electron deficient, and so when we bring an aromatic around in a secondary addition, the carbocation is enough to get the benzene to break its aromaticity and go in and attack. So remember, the benzene that's pictured has 6 hydrogens, 1 on each carbon. I haven't written in any of the others except for the one on the carbon that ended up making the new attachment to the acyl carbon. Our polyatomic is still around, and we're going to utilize that. The chlorine that attacked the aluminum, or one of the others, they're just alike, is going to take the electrons back from the aluminum and make a new bond to the hydrogen. Okay. Here again, hydrogen only ever makes one bond, so as it accepts that new bond, it has to let go of the old one, and so the carbon that it was attached to is going to take those electrons, make a new bond to the carbon next door, and there's our methylphenyl ketone. We get aluminum chloride as a byproduct. It's reformed, or catalyst, and we get HCl, which bubbles out, which will drive any equilibrium that wants to be made to completion. Procedural notes for this lab. Set up your apparatus, including the dish for your ice bath, and you can even start to go ahead and put some ice in it, but try not to get the glassware too cold until you're ready to get the things in there. If it's cold and open to the atmosphere, it'll start sucking moisture in, and these are somewhat moisture sensitive. Measure 40 mils of dichloromethane and have that ready. Okay. Don't measure 15 and then 25, etc. Just measure 40 and use out of that. Okay. Measure the aluminum chloride into a weigh boat in the instrument room, but realize it is extremely hygroscopic. And once it's absorbed enough water vapor, it's useless for this reaction. So keep it capped if there's no one waiting right behind you in order to use it. Bring it back, add it right away to your round bottom. I would have wiped the neck out with a Kim wipe so that it's not real greasy. And then use 25 mils of the dichloromethane that you have ready to rinse that down and start to dissolve. It won't dissolve, all of it dissolve, but it'll get the process started. Measure the acetyl chloride with glass, please, 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 no plastic. And you want to measure that by volume and then use the density to figure out exactly how much you've got. Add that to your step funnel with some dichloromethane, and then you're going to use the separatory funnel to drip the acetyl chloride solution in slowly. Okay. The SEP funnel will need to be topped with a drying tube, not your stopper, else it will create a vacuum. And the same thing is true for your reflux condenser, so you'll have 2 drying tubes this left. As we said during the mechanism, hydrogen chloride is a side product, so don't cook it too fast. You don't want the HCl getting out of the condenser. Yes, you'll have your drying tube with bicarbonate in there to neutralize it, but let's not take any chances. Okay. Notice the asterisk here. This, the rest of this will be done the following week. Okay, so you're gonna stopper your 3-neck flask well. Make sure each of the stoppers is well greased. If we need extra Teflon stoppers, etc., we've got them. Okay, leave them in your drawer. Next week, we're gonna start by pouring the reaction mixture into some HCl. That is a very violent reaction. We're gonna wanna do it in the hoods, and you're gonna wanna pour very slowly. When you're ready to that point, you want to decant into a round bottom that you know the mass of, and do a simple distillation to remove the dichloromethane. Okay, which means your product, which has a higher boiling point than the dichloromethane, is remaining in the source flask. Don't cook it too hard. You don't want to decompose your product. Okay, but you want to drive the dichloromethane over to the receiving flask. The receiving flask should probably be iced to promote condensation and have it come over. And you'll need to apply a vacuum from the house vacuum to the vacuum adapter at the end of that distillation to make sure that you've evaporated all the dichloromethane out of your source flask. Once you have that done, get a mass on it, get an IR on your product, get it appropriately labeled with a blue label, turn it in the blue basket. Please, please, please make sure and label it with what is in it. It is not Friedel Crafts. That's what you did to it. Okay, I need to know that exactly what the product or products are. Some of these have 2 different products. You need the name of both of them on the label. Okay. As far as the reaction progression, here again, these pictures were done the very first semester we taught here. And we didn't have the glass dishes that we now have that will be out. And so they were using as big a beaker as we had as their ice bath. But you can see the aluminum chloride is a nice bright yellow. And some of it is dissolved, but not all of it. As the reaction progressed, the entire solution turned colors. And then we started getting a second layer, and then the workup.